All right, guys. Now we have come again to this very interesting topic called relative velocity. You see this topic? This topic is the topic that made Albert Einstein to ask himself a very hard question. Like, it made him to start seeing the universe in a different way. And after thinking, he concluded that even time and space is what? Relative. In fact, there is no absolute time or absolute space. But we are not here to talk about Einstein's theory of relativity. We are here to talk about relativity, that's relative motion in Newtonian physics, okay, or in classical physics. Now, in discussing this relative motion, we consider time and space as absolutes, okay? So that is, time is not relative, okay? It is absolute, both of them, time and space. Okay, let us define relative velocity. What is relative velocity? Now, relative velocity is the velocity of an object as observed from another object in motion or stationary. That is relative velocity. That is the velocity of an object as observed from another object, whether that object you are observing from is moving or what? Stationary. Do you understand? So now it is defined like this, like VAB, the velocity of A with respect to B. That is, when I wrote VAB, what I mean is the velocity of A with respect to B. That is how the person from B will see the velocity of A. That is what we actually mean. So it is equals to what? VA minus VB. You know, we are comparing here. We are comparing how much VA is greater than what? VB. That is what we are actually comparing. Okay? A magnitude and direction. Okay? So now, assuming that you are in a car moving towards east with a velocity VA, how do you see cars that are moving opposite of you? Remember, this direction is positive. How do you see cars that are moving opposite of you? Cars moving opposite of you with velocity VB. How do you see them? Do you see them as fast or slow? Do you see them as fast or slow? Are they moving fast or are they moving slow? The answer is that they are moving fast. Now, what velocity are you actually seeing? See the velocity that you are seeing. Now, the velocity that you are seeing is, see it here. Now you are seeing this velocity, this combined velocity, VA plus what? VB. You are seeing the sum of the two velocities. That is the velocity of your own velocity, plus the velocity of the car moving opposite of you. But when we consider it a magnitude and direction, see what you are seeing here. Look at it here. Now, in that case, we express relative velocity. We express relative velocity, and that is VAB. Remember, your direction is positive. This one is what? Negative. So, is VA minus what? VB. Because this one is negative, we now have VAB is equal to VA minus bracket minus VB, because the direction of this one is negative. So, VAB is equal to what? VA plus what? VB. Do you understand? So, see, this is velocity of A with respect to B. That is, it means that the person in the other car, will see a combined velocity in the other direction, that is opposite to him. Remember, he's moving in negative direction compared to you. Do you understand? With respect to you, he or she is moving in negative direction. Do you understand? So he or she will see you moving in the opposite direction. That is why this combined velocity is what? Is plus. Do you understand? Now, let us now consider the velocity of him or her with respect to you. That is velocity of this car here with respect to you. That is how you will see it. Now watch now. So see how you will see it here. So how you will see it is VBA, okay, equals to VB minus VA. Remember, you are moving, your direction is positive. The direction of this one is what? Negative. Now watch. Now VBA is equal to, this is minus VB minus VA. You know, this is how it will look like. So VBA is equals to minus bracket VB plus VA. Okay, so therefore VBA is equals to minus VAB. Remember, this is VAB, VA plus VB. Remember in the other example. So VBA is equals to minus VAB. Now, see what you are seeing. You are seeing the same combined velocity, the same sum, that the sum of the two velocities, but in the negative direction. Are you seeing it now? It is mathematically expressed. Do you see? In the negative direction. That is the meaning of this minus here. Do you understand? So you will see the car pass in the negative direction. The combined velocity, what you saw is a relative velocity. It is not the actual velocity of this car. Do you understand? So this is clearly the relative velocity in one dimension. We have relative velocities in two dimensions. That's what I will consider in my next video. Okay, this topic is very, very, very interesting. In fact, if you go far in it, it will lead you to the theory of relativity in physics and about Einstein's theory of relativity. Like I said in the beginning of this video, time in Einstein's relativity, time and space, they are relative, unlike in Newtonian physics. Okay, so that is it. Even time and space. And Albert Einstein included time and space as relative entities. Okay, so that will be in my next video. I hope it's very, very clear. So in my next video, we'll talk about relative velocity in two dimensions. See you guys in my next video.